Dear students, welcome back. So in this class, now let us discuss about Cauchy sequence and Cauchy criterion. So what is a Cauchy sequence? Consider a sequence x equals xn. The sequence xn is said to be Cauchy only for all epsilon positive there exists k following n. There exists a natural number k such that modulus of xn minus xm strictly less than epsilon for all n comma m greater than or equals k. So any sequence xn satisfies this condition. The sequence xn is said to be a Cauchy sequence. The sequence xn is said to be a Cauchy sequence. Means modulus of xn minus xm strictly less than epsilon for all n comma m greater than or equals some k, where k is any natural number, then the sequence xn is said to be Cauchy. For example, consider sequence 1 by n. Sequence 1 by n is a Cauchy sequence. How? What about modulus of 1 by n minus 1 by m? Modulus of 1 by n minus 1 by m is less than or equals modulus of 1 by n minus 1 by m. Or consider the sequence xn. Let xn equals 1 by n. So what is xm? Xm equals sequence 1 by m. Enough. That epsilon is positive. Take epsilon is positive. Then choose k following n such that k greater than 2 by epsilon. Xn is 1 by n. Then xm equals 1 by n. Choose epsilon is positive and setting k following n with a k greater than 2 by epsilon. So what about mod xn minus xm? We have to show mod xn minus xm less than some epsilon. What is mod xn minus xm here? Mod xn minus xm means modulus of 1 by n minus 1 by n. Mod 1 by n minus 1 by m, it is less than or equals 1 by n plus 1 by n. Sure. What is 1 by n? So for all n comma m greater than or equals k, for all n comma m greater than or equals k, so what is 1 by n? 1 by n less than or equals 1 by k. What is 1 by k? 1 by k means it is strictly less than epsilon by 2. Similarly, 1 by m also less than epsilon by 2. So it is strictly less than epsilon by 2 plus epsilon by 2 equals epsilon. Means mod xn minus xm strictly less than epsilon for all n comma m greater than or equals k. So according to our definition, sequence xn means sequence 1 by n is a Cauchy sequence. Agree? So you can choose k. K is choose in this way, k greater than 2 by epsilon. So for all n comma m greater than or equals k, surely 1 by n strictly less than epsilon by 2 according to this choice. Similarly, 1 by m strictly less than epsilon by 2. So mod xn minus xm strictly less than some epsilon. Enough. So now come to a result, means there is a lemma. The lemma states that if x equals xn is x equals xn be a sequence of convergent sequence of real numbers, then x is Cauchy. Means x is convergent, that implies Cauchy. Means every convergent sequence is Cauchy. That is what we recurse here. Xn is a sequence of real numbers, is a sequence of convergent sequence. That's a sequence of real numbers which is convergent or convergent sequence of real numbers. Then we show that the sequence is Cauchy. Means every convergent sequence is Cauchy. How? For suppose let secant xn, x equals secant xn converges to some x following r. That means by definition, for all epsilon positive, there exists some k1 or k following n such that modulus of xn minus x strictly less than some epsilon by 2 for all n greater than or equals k. Agreed. Therefore, for n comma m greater than or equals k, consider, to prove it is Cauchy, consider modulus of xn minus xn. Modulus of xn minus xn can be rewritten as it is xn minus x plus xn minus xn. So, by the triangle inequality, it is less than or equals modulus of xn minus x plus modulus of x minus xn. X minus xn means xn minus x. So, what is modulus of xn minus x? Strictly less than epsilon by 2 for all n greater than or equals k. So, mod xn minus x less than epsilon by 2 for all m greater than or equals k. So, for all n comma m greater than or equals k. That means modulus of xn minus xn strictly less than epsilon for all n comma m greater than or equals k. That means secant xn is Cauchy. So, if a sequence is converges, if a sequence of real numbers is converges, then it is Cauchy. Means every convergent sequence of real numbers is a Cauchy sequence. That's an important result. Every convergent sequence of real numbers is a Cauchy sequence. Now, consider another lemma, another result. A Cauchy sequence of real numbers is bounded. Cauchy sequence of real numbers is bounded. Previous lemma states that convergent sequence is Cauchy. Here we try to prove Cauchy sequence is bounded. How? So for let x equals xn be a Cauchy sequence of real numbers. X equals xn is Cauchy. X equals xn is Cauchy means for all epsilon is positive. So for convenience, only for the sake of argument, put epsilon equals 1. Then there exists some k following n such that modulus of xn minus xn strictly less than epsilon. Instead of epsilon, here it is 1 for all n comma m greater than or equals k. But we have modulus of xn minus xn less than 1 for all n comma m greater than or equals k. So in particular, modulus of xn minus xk strictly less than 1 for all n greater than or equals k. Okay. In particular, so modulus of xn minus replace m by k, why? Because m greater than or equals k, the results follow here. So mod xn minus xk strictly less than 1 for all n greater than or equals k. Then mod xn minus mod xk. Mod xn minus mod xk less than or equals, we know that it is modulus of xn minus xk. Sure? Okay. Mod xn minus mod xk less than or equals mod xn minus xk, but mod xn minus xk strictly less than 1 for all n greater than or equals k. For all n greater than or equals k. That means modulus of xn strictly less than 1 plus modulus of xk for all n greater than or equals k. Enough? Put up m equals maximum of mod x1, mod x2, etc. mod xk, comma 1 plus mod x. Mod x1, mod x2, etc. mod xk plus 1, comma 1 plus mod xk. So from here, then clearly you can say that mod xn less than or equals capital M for all n fallen n. Agreed? For all n greater than or equals k, but k fallen n. So for all n fallen n. So mod xn less than or equals m means clearly secant xn is bounded. Agreed? So these are two important results. One is every convergent sequence is Cauchy. Every convergent sequence of real numbers is Cauchy. And the second result is every Cauchy sequence of real numbers is bounded. Convergent sequence is Cauchy and the Cauchy sequence is bounded. Clear? Now let us consider the Cauchy criterion. What is Cauchy's criterion? Cauchy's criteria means a sequence of real numbers. Consider the criteria. A sequence of real numbers is convergent if and only if it is Cauchy sequence. A sequence of real and Cauchy's criteria is an important result. Cauchy's criteria. A sequence of real numbers is convergent. Sequence of real numbers is convergent if and only if it is a Cauchy sequence. It is a Cauchy sequence. This is Cauchy's criteria. A sequence of real numbers is convergent, then it is Cauchy. Reversely, a Cauchy sequence is always convergent. So how? Let's prove. First part is immediate. Come to the necessary argument. This is the necessary argument. A sequence of real numbers is convergent. Let x equals xn be a sequence of real numbers. We already proved that x equals xn be a sequence of real numbers which is convergent, then it is Cauchy. That is our first lemma. In first lemma we proved that every convergent sequence is Cauchy. So here, let x equals xn be a convergent sequence of real numbers. Hence, immediately secant x by lemma 1 by lemma 1, it is secant xn is Cauchy. So, first part is immediate. Now come to the reversing version. What about the sufficient argument? For sufficient argument, suppose x equals xn be a Cauchy sequence. Let assume x equals xn is Cauchy. X equals xn is Cauchy. The second lemma states that by previous lemma, by second lemma states that every Cauchy sequence is bounded, therefore secant xn is bounded. Agreed. So secant xn is bounded means by Bolzano-Weierstrass theorem. By Bolzano-Weierstrass theorem. What is Bolzano-Weierstrass theorem? Bolzano-Weierstrass theorem states that the theorem Bolzano-Weierstrass theorem states that a bounded sequence of real numbers is a convergent subsequence. Okay. Here secant xn is bounded. So Bolzano-Weierstrass theorem states that every bounded sequence of real numbers has a convergent subsequence. So according to that argument, secant xn has a convergent subsequence. Secant xn has a convergent subsequence. Later, x dash equals secant xn k be a convergent subsequence of x. X equals xn. Let x dash equals secant xn k be a convergent subsequence of x. X means xn. Secant xn. Assume xn k be a convergent subsequence means xn k converges. So let secant xn k converges to some x star. Secant xn k converges to some x star. But what is xn? Secant xn is Cauchy. That's our assumption. Secant xn is Cauchy. Secant xn is Cauchy means for all epsilon positive, there exists some k1 fallen in n such that modulus of xn minus xm strictly less than epsilon by 2 for all n comma m greater than or equals k. Agreed? Okay. So you can mark this one. Again, what is x dash? X dash is secant xn k, but secant xn k converges to the x star itself means secant xn k converges to x star means limit xn k equals x star. Agree? So by definition, for all epsilon positive, there exists some k2 fallen in n such that modulus of xn k minus x star strictly less than epsilon by 2 for all nk greater than or equals k2. Agree? Mark this equation 2. Now you construct k. Put a k equals choose k equals maximum k1 and k2. So these two results, two equations, 1 and 2 are called for this k itself. That means, now consider, that means modulus of xn minus xn less than epsilon by 2 for all n comma m greater than or equals k, and modulus of xn k minus x star strictly less than epsilon by 2 for all n k greater than or equals k. Now consider modulus of xn minus x star. Modulus of xn minus x star. What is modulus of xn minus x star? This can be rewritten as xn minus xn k plus xn k minus x star. Okay. By using triangle inequality, it is less than or equals modulus of xn minus xn k plus modulus of xn k minus x star. What is modulus of xn minus xn k? Modulus of xn minus xn k strictly less than epsilon by 2, that is true for 1. When m is, we can replace. So, mod xn minus xn star also strictly less than epsilon by 2 from equation 2. So, it is true for, this equals or strictly less than epsilon by 2 plus epsilon by 2 equals epsilon, that's for all n for all n s greater than or equals k. That means modulus of xn minus x star strictly less than epsilon for all n greater than or equals k. That means xn converges to x star. What is xn? Xn with our Cauchy sequence. So the Cauchy sequence converges to some x star, means Cauchy sequence converges. So this is the Cauchy's criterion. The Cauchy's criterion is that the Cauchy's criterion plays an important role in real analysis. That is, every Cauchy sequence of real numbers is convergent. Every sequence of real numbers is convergent, then it is Cauchy, and every Cauchy sequence of real numbers is always convergent. Agree? Okay. So, Cauchy sequence. Cauchy sequence, what is the Cauchy sequence? Mod xn minus xm less than epsilon for all n comma m greater than or equals some k, where k is a natural number. And we prove two lemma, Cauchy sequence is convergent sequence is always Cauchy, and the Cauchy sequence is always bounded. Moreover, the Cauchy's criterion is sequence of real numbers is convergent if and only if it is a Cauchy sequence. Agree? Okay. Now, consider a sequence. Consider a sequence 1 by 1 plus 1 by 2 plus 1 by 3 plus etc. plus 1 by n diverges. How to prove this one? 1 by 1 plus 1 by 2 plus 1 by 3 plus etc. plus 1 by n diverges. How to prove this one? So for let xn equals 1 plus 1 by 2 plus 1 by 3 plus etc. plus 1 by n. Okay. For all n fallen n. Clear? So what is xm? xm equals 1 plus 1 by 2 plus 1 by 3 plus etc. plus 1 by m for all m fallen n. Enough? If m greater than m greater than n. So what about xm minus xn? Xm minus xn equals 1m greater than n. So 1 by 2, 1 by 3 etc. all are cancelled. What's the means here? It is 1 by, xm minus xn, it is 1 by n plus 1 plus 1 by n plus 2 plus etc. plus 1 by m. Okay, when m greater than n means n, the next term is n plus 1, n plus 2 etc. So 1 by n plus 1, 1 by n plus 2 etc. So xm minus xn is 1 by n plus 1 plus 1 by n plus 2 plus etc. plus 1 by n. Okay, that means each of these m, how many terms are there? How many terms are there? There are m minus n terms. Sure? M minus n terms. Each of these m minus n terms always exceeds 1 by m. Each of these m minus n terms exceeds 1 by m. Agreed? Okay. That means modulus of xm minus xn, modulus of xm minus xn strictly greater than it is m minus n by m. This m minus n terms always exceeds this 1 by m. So that means modulus of xm minus xn greater than this m minus n terms m minus n by m. That is m minus n by m means it is 1 minus n by m. Okay. 1 minus n by m, put m equals to a. Put m equals to a. Why? Our choice is m greater than n. When m equals to n, it is 1 minus n by m means 1 minus n by 2n equals 1 minus 1 by 2 equals 1 by 2. Sure. When m equals to n, it is mod xn minus modulus of xn minus xn greater than 1 by 2 for all n comma m greater than or for all n comma m is present in n. So by Cauchy's criterion, secant xm minus xn greater than 1 by 2 by Cauchy's criterion, secant xn does not converges. Secant xn does not converges means secant xn diverges. For Cauchy's criterion, secant xn converges when xn is a Cauchy sequence. Cauchy's criteria says that secant xn converges, then it is Cauchy. When xn is Cauchy, should be converges. Here, mod xn minus xn greater than 1 by 2 means secant xn is not a Cauchy sequence. It is not a Cauchy, hence by that criterion, secant xn always diverges. Enough. Thank you.